Okay, for our example number 3, sabi dito, water flows through a venturimeter at a steady rate. At the section where the area is 50 centimeters squared, the height of the liquid in the vertical tube is 10 centimeter. So, I assume, ito yun. Kasi ito lang naman yung height ng 10 centimeter. Ayan. And then, while at the section where the area is 90 centimeters squared, the height of the liquid in the vertical tube is 20 centimeters. So, ito yun. Determine the velocity of the water in the main pipe, the velocity of the water in the constriction, and the rate of flow. So, basically, class, ang pinapahanap sa inyo dyan is yung V sub 1, V sub 2, at saka yung discharge niya, which is yung Q. So, find. Ayan, yung tatlo na yan. And then, may mga ninotes ako dito, makikita nyo sa left side, which is yung conversion ng gravity at saka yung conversion ng density na alam nyo. Ang alam nyo dyan kasi is ito, at saka itong 1,000, di ba? Pero, gagamitin natin yung other two, which is yung ito, at saka to, kasi nakabigay sa problem nyo is uniform ng centimeter. So, ang gagamitin natin dyan kapag ka uniform na puro centimeter, yung binigay ko sa inyong table of units, which is yung centimeter, slugs, hindi pala slugs, centimeter, dynes, so grams, so yun yung mga gagamitin natin ngayon. Okay? So, paki-check dun sa may table of units nyo kung ano yung uniform. Di ba kapag meter ang gagamitin natin, meter, kilogram, newton, dito, this time, ang gagamitin natin, centimeter, grams, at saka dynes. Okay? So, kaya ko nilagay yung mga yan. And makikita nyo rin, class, sinulat ko din dito, yung 20 minus 10 na yan kasi yan yung height difference nila and gagamitin natin yan sa pagkuha ng pressure difference. Kasi ito, may equivalent pressure yan, ito din may equivalent pressure yan, pero kukunin natin yung pressure difference nilang dalawa. And again, kagaya nung sinabi ko sa inyo nung umpisa, kapag ka venturimeter yung problem na na-encounter nyo, ito lang naman ang formula. Yung tatlo lang naman na to. Yan. Yung tatlo na to. So, yan yung gagamitin natin ngayon. Pero since meron kayo nakagiven na cross-sectional area, ito na. Yung gagamitin natin. Yung formula number 3. And para makuha natin yung pressure difference, ito gagamitin natin. Yung formula number 2. Okay? So, sulat natin. So, solution. Ayan. Solution. Ang pressure difference P sub 1 minus P sub 2 is equal to rho GH. And then, yung isa pang formula natin is P sub 1 minus P sub 2 is equal to rho V sub 1 squared over 2. Pakicheck nyo class sa formula nyo. Times quantity, A sub 1 squared over A sub 2 squared minus 1. So, kapag alam yung density, alam nyo na yan, given yan, kasi water lang naman to. Yung area 1, alam natin yan. Area 2, alam natin yan. Ang pinapahanap sa ating class is ito. Yung V sub 1 na yan. And then yung pressure sub 1, tsaka minus pressure sub 2, dito natin kukunin. Okay? So, dito natin kukunin yan. So, substituting yung mga values na alam natin, tandaan nyo class na ang gagamitin natin units dito is dynes, grams, at saka centimeter. Okay? So, ang density ng water kapag naka-centimeter, naka-centimeter at saka grams is equal to 1 gram per cubic centimeter times yung gravity. That is 981. Sinulat ko na ito, 981 centimeter per second squared. So, kapag pinag-multiply nyo, ito, tsaka ito, tsaka ito, kakalabasan yan, dynes. Times, yung height natin, height difference natin. So, ito yun. So, this is 20 minus 10. So, paki-input sa calcul nyo class yan. So, this is 1 times 981 times 20 minus 10. Ayan. So, that is 9,810. 9,810 dynes na to, class. Pagka uniform kasi, class, ang nakagiven, kagaya sinasabi sa inyo, check nyo yung units nyo. Dynes per centimeter squared. Then, after nyan, pwede na nating input yung mga given values natin. Naka-centimeter lahat, no? So, input nyo, class, this is 9,810 dynes per centimeter squared. So, kahit hindi na, so kahit wag nyo na ilagay units, uniform naman na, that is equal to, density natin, that is 1, times V sub 1. V sub 1 natin is squared over 2 times quantity. Area 1 natin. Area 1 natin is, binigay na yan eh. So, 50 cm squared daw, yung height daw natin is 10 cm. So, ito yun, 50 cm squared. And then, yung isa naman, 90 cm squared naman to. 19 cm squared naman dun sa height na 20 cm. So, ayan, correct. So, this is 90 cm squared. Ito huwag nyo na ilagay. Squared over 50 and then squared minus 1. So, pwede nyo class i-shift solve dyan, pero ako, ang gagawin ko dyan, ililipat ko tong 2 na to sa kabila. So, magiging 9,810 times 2 is equal to V1 squared times. I-calculate nyo na to, class. I-calculate nyo na yan para ma-simplify natin. Calculate nyo na yan. That is 90 squared over 50 squared. So, that is, tapos minus 1. 2.24. So, this is 2.24. And then, lastly, para makuha natin V sub 1 is equal to square root. Ilipat nyo to sa baba dito. That is square root ng 9,810 times 2 over 2.24. So, since uniform na yung mga units natin, centimeter per seconds na yan. Square root ng 9,810 times 2 over 2.24. So, this is 93.59 centimeters squared. This is 93 point, no ngayon, 0.59. 59 centimeter per second. Ito class yung final answer nyo. Next, para makuha natin yung V sub 1 at saka yung discharge, yung general formula na lang gamitin natin. Di ba? General formula that A sub 1, B sub 1 is equal to A sub 2, B sub 2. Kaya ko sa inyo pinapamemorize yan. So, substituting yung A sub 1 natin, that is 90 squared, and then V sub 1, that is 93.59. Okay? And then, is equal to A sub 2, that is 50. Bakit may squared? Walang squared yan. And then, times V sub 2. Therefore, ang V sub 2 nyo is equal to, input nyo lang kasi yan sa calcu din. So, that is 90 times 93.59 over 50. So, this is 168.46. 168.46 centimeter per second. Ito class yung velocity sub 2 natin. And then lastly, para makuha natin discharge, you have Q is equal to AV. Diba? So, kahit alin sa dalawa na yan, kahit alin sa dalawa na yung gamitin nyo, dapat equals lang yan. So, Q is equal to, ang gamitin natin yung A sub 1, B sub 1. That is 90 times V sub 1 natin, that is 93.59. 90 times 93.59. This is 8,423.1. Since centimeter to, this is centimeter per cubic centimeter per second. Cubic centimeter per second. So, ayan. Yan. Gusto nyo itry yung isa, pagka itinry nyo naman yung isa, that is 50 times 168.46. So, same lang yan dapat. So, same lang yan. Kaya, kahit hindi nyo na-class itry. Okay? So, ganyan lang. Pagkuha, kapag ka venturimeter yung problem, basta ang pinaka-critical lang dito sa problem na na-solve natin na to is yung units. Kasi, ang nakagiven sa problems nyo is per centimeter. So, definitely, dapat uniform yan. Okay? Kaya gumamit tayo ng centimeter, grams, at saka dynes. Pero yung formula, kapag kakabisado nyo yung formula na to, you are good to go. And then lastly, para sa last problem natin, direct substitution lang din to. Sabi dito, a water tank has an orifice of 8 centimeters squared in one vertical side. Kaya sabi kagaya ng sinabi ko sa inyo kanina, kapag ka orifice yung problem, ang gagamitin natin is yung isang formula. Orifice yan. Orifice ang tawag dyan kapag ka butas. So, a water tank has an orifice of 8 centimeters squared in one vertical side, 3 meter below the free surface level in the tank. Determine the velocity of the discharge if the cross-section of the stream contracts to 64% of the area of the orifice. Determine the rate of flow. Ang pinapahanap sa atin is yung velocity at saka yung basically, ang pinapahanap sa atin is yung velocity at saka yung discharge na gagamit tayo ng 64% nung cross-sectional area lang niya. So, ayan. Eh, di ba? Meron tayong formula, solution, na kapag ganito class ang type ng problem, tandaan nyo, whole to ha, whole. Or butas. Ito na yun, di ba? Kapag ganitong type ng problem, ang binigay sa atin, ito na, yung dalawang formula lang na yan. So, basically, gagawin natin is, ang gagawin lang natin dyan is, gamitin natin yung formula which is V is equal to square root ng 2GH. Ayan. So, V is equal to square root ng 2 times 9.81 meters per second. Naka-meters naman. And then yung 8, i-convert na lang natin sa meters mamaya. Meters times yung height natin. May binigay bang height? 3 meters. So, 3. So, therefore, V is equal to square root ng 2 times 9.81 times 3. So, this is 7.67. 7.67 meters per second. So, ayan. And then, lastly, para makuha natin to, yung area kasing binigay class is 8 cm. 8 cm squared. So, i-convert natin yan. I-convert natin yan. Para makuha natin discharge is equal to, sabi ganon, merong condition, 64% lang. 64% of the area of the orifice. So, kung meron tayong given area, ang formula discharge natin is Q is equal to V. Eh, meron na tayo class V, di ba? So, input na natin yan mamaya. Pero, meron tayong condition na 64% lang gagamitin natin. And tandaan nyo class, kapag ka 64, that is 0.64 AV. Okay? Pero meron tayong given area that is equal to 8 cm squared. Convert natin class sa meter. 100 centimeter is equal to 1 meter. So, area is equal to So, convert natin class. That is, pero dapat naka-square din to. Naka-square din to. Kasi naka-square yung i-convert natin. So, bridging. Tinuro yan sa bridging. So, 8 times 1 over 100 squared. So, that is 0.0008. So, this is 0.0008 meter squared. So, ayan. And then, input nyo class dun sa equation natin, that's Q is equal to 0.64 times 0.0008. And then, yung velocity natin nakuha, that is 7.67. Therefore, ang discharge natin using 64% ng cross-sectional area lang ng orifice is equal to, input nyo class. So, that is 0.64 times 0.0008 times 7.67. So, that is 0.003, 0.0033927 cubic meter per second. So, ito class yung final answer. Ayan. Check ko lang ha. 1 over 100 and then square. Tama naman. So, ayan. Yung nasa module nyo class, may mali dyan. May mali dyan class sa module nyo. Ang nakalagay kasi dyan is 0.0064. So, hindi naman yun class ang given area. Ang given area natin is 8 cm squared. So, paki-correct na lang. Okay? So, eto class yung correct answer. So, ayan. Ganyan lang class. Mag-solve ng fluid dynamics. Basta tatingnan nyo kung anong type of problem and then i-input nyo yung correct formula na pwede natin gamitin. So, hanggang dito lang yung discussion natin para sa fluid dynamics. Thank you so much.